Alright, the Benny gun. When we left off, we last saw you hiding up in a tree as Benny was preparing to shoot his scorpion gun at you so that he could share his scorpions with you. Let's bring the situation into focus and get after some problem solving. That's not focus. Focus more. Alright, so what Benny wants to do is Benny is going to aim his scorpion gun so that it's directly in your face. So when Benny looks down the sights of his homemade Benny-made scorpion gun, he sees your face and he thinks you're so happy to see him. He's Benny, he wants to share his scorpions with you, and he doesn't understand why you would say, Benny, no, but you know that you're about to get scorpions shared with your face. So you think, being clever as you are, that while Benny aims at you, that you are going to do something really smart, like let go of the tree branch above and fall straight down. The problem is that when you do that, our physics tells us that somewhere along the way down, if you let go of the tree branch at the exact same time as Benny fires the scorpion gun, gravity is going to act on both of you. Benny's scorpion as a projectile, you as a free-falling object, and this happens. And you and Benny's scorpion are going to be very good friends, as Benny intended all along. Benny's scorpion really likes having brand new friends like you. So I posed the question, does the initial velocity matter? And I also asked, can you prove that this will happen? So we're going to take a look at what it would take to prove that the Benny gun full of scorpions would actually hit you in the face if you let go of the tree branch right when he fired it. And we're going to do this by taking a look at the projectile concepts that are involved in both your motion and the scorpion's motion. So instead of breaking this down into X and Y pilot, we're going to break this down into scorpion and you. So scorpion. There he is, looking nice and happy today, and you. Not quite sure what's going on in your life that these things keep happening to you. So something that's true for the scorpion. Alright, well this is projectile motion, so the scorpion has an X pilot experiencing uniform motion. So the scorpion will be experiencing a displacement depending on its initial velocity in the X direction and time of flight. In the Y direction, the scorpion will be moving from his original location, and he will be moving according to his initial y velocity times time minus 1/2 gt squared. Alright, so that means that I've set my axes as I did earlier with up in the positive y direction and moving toward you in the positive x direction. I'm going to simplify things just a little bit. I'm going to say that for this problem, the initial position of the scorpion is our origin. So here's the origin, and that's going to make our initial y position 0. So we could say that the scorpion's equation is actually just that the scorpion's position is going to be dependent on the scorpion's initial y velocity times time minus 1/2 acceleration due to gravity times time squared. All right, that's scorpion's equation systems. All right, we've got his x and his y variables, because the scorpion in this scenario, the Benny gun scenario, does in fact become a projectile. You, on the other hand, are only experiencing free fall. Lucky you. So one thing that we can say about you is that you will be falling from some initial position, and you will be falling according to your initial velocity in the y direction times time minus 1/2 the acceleration due to gravity times time squared. Now we can simplify your equation too, because you're just letting go, you're dropping. So that means your initial velocity is 0. We can eliminate this from the equation. This is important because simple is better. All right, so you're going to be dependent on your initial position, which in this case does not go away because the whole problem has this as the origin. All right, so if the whole problem has this in the origin, then your position right here is some value other than 0. But your position is only going to change in accordance with the acceleration due to gravity and the time that you fall. So our system of equations includes the projectile motion of the scorpion and the free fall motion of you. If we're going to show that you and the scorpion are about to become the bestest friends ever, then there are 3 things that must be true. In order for you and the scorpion to become the bestest friends ever, the time must be the same for the scorpion's equations and for your equations, because we are going to be considering the moment that you and the scorpion come together, and we're assuming that the initial time was the same for both, the second that Benny pulled the trigger to release the scorpion. Another thing that must be true in order for you and the scorpion to become the very best good friends, that must mean that the y for the scorpion must equal the y for you, because the only way for you and the scorpion to collide is for you to be at the same point along the y-axis. And then the third thing that must be true is that your collision between you and the scorpion must happen at x. So all of this must happen at the position x away from the origin. Otherwise, it doesn't matter if the scorpion is here and you're here. It doesn't matter if you're the same on the y position. If you're not at the same location, you and the scorpion will not become best friends. And remember, we're going to consider a situation in which you and the scorpion become best friends. So we're going to say that all of these things, the time being the same, the y position being the same, and everything happening at an x position where you are away from Benny, all of these things we're going to say are true. And that's going to help us solve this problem. All right, because we're trying to see if we can prove whether or not V naught matters mathematically. And so we're going to have to look at how V naught is in relationship to all 3 of these values using these 3 equations. So we're going to take our 3 equations and we're going to start solving the Benny gun. All right, so our system of equation is also going to be including the initial velocity with which the Scorpion was released from the Benny gun. All right, because we know that this velocity was a vector, we can break it down into its x and y components. So the v naught in the y direction is going to be v naught sine theta, and the v naught in the x direction is going to equal v naught cosine theta. And those should be incredibly familiar values to you by now. And we're also going to take a look at what else is true. All right, we decided that the y of the Scorpion equals the y of u. So we're going to take those two equations, ys equals and y equals, and we're going to set them equal to each other. And we're going to do it just like this. We're going to say that vy naught times t minus 1/2 gt squared equals y naught minus 1/2 gt squared. Right? And we did that because we decided that if you're going to collide, those two values are equal to each other. And this is a fundamentally important thing that has to be true, because both of you are getting acted on by gravity. Both of you are experiencing free fall. One of you free fall with no horizontal direction. One of them is free fall with vertical direction. But both of them have the same effect of gravity, which means that in the end, this gravity is not a contingent function, right? That goes away, which means that your velocity in the y direction times time is going to be equal to your initial position. Remember, this is the position that you were above Benny and his projected Scorpion. Now, because we know that the y velocity was a vector component of the initial velocity, we're going to go ahead and we're going to do that substitution now. We're going to say that v naught sine theta times time equals that position. So one thing that we can say is for a projectile with an initial velocity, right, the position and whether or not it relates to you is going to be dependent on the initial velocity and initial angle. But it's also dependent on time. And we know that time is the connecting point between the x and the y pilots. So we're going to take a look at the other Scorpion equation, which is x equals v naught cosine theta, where I went ahead and I did the substitution right away, times time. And this time are the same. So that means I have a system of equations here where they both have v naught, which we're interested in whether or not that's going to be an important factor. And we also have time. And we said that it was really important for us to understand that this happens at the same time. Right? So we said that you and the Scorpion have to be at the same height at the same time, and that time must be the exact same time at which this position is achieved. And since we're making all three of these variables the same, then that means that we could solve this equation for time. And since this time is the time of this collision, we can do a substitution, and we can say that at the moment where the Scorpion and you collide in the face, by the way, you have v naught sine theta times x over v naught cosine theta, and that's going to be related to your initial position. And this is the relationship that brings the x, the y, and the t all together. This is where the time relates to the vertical position and the time relates to the horizontal position, and we used a system of equations to substitute in for time. Now that we've done that, we can see that that initial velocity goes away. Therefore, I can already answer before I've simplified the equation that no, the initial velocity did not matter in order for the Benny gun to work. So it doesn't matter how powerful the Benny gun is. It just so happens that he's going to hit you one way or the other. Now we have sine theta over cosine theta. And if we use our trigonometric identities, we know that that's going to equal tangent theta. So when we simplify the equation, we're going to get x tangent theta is going to be the relationship with y naught, which means that the only things that matter in the system of equations are that the relationship between Benny's displacement from you and your initial position is related by his angle of fire, tangent theta.